Bismillahirrahmanirrahim. Assalamu alaikum, dear students. Today we are starting a last topic of chapter number 8, that is Doppler's effect. Okay, today we are studying another topic, that is Doppler effect. So, how we can define Doppler effect? So, let's have a look to the definition. The apparent change in the frequency of sound due to the relative motion of source and listener is called Doppler's effect. Okay, it's called Doppler effect. So Doppler effect tells about the change in frequency. But remember, the frequency does not change really in actual. But we feel that the frequency is changed. If we feel that the frequency is changed, so that is called the apparent change. Means just we are observing the frequency is changed. So that frequency, the change in frequency is called the apparent frequency. Okay. Suppose when we have a source, suppose we have a source, it produces sound, and there is a person who is a listener. Then when we uh, ringing this device, so it will produce a sound, and this sound will travel to the person. So it means that the person will hear the speed of sound with the frequency f. Now, if the source moving towards the listener, then we notice that the frequency of sound will be increased. Or when we observe the listener is moving toward the source, then the frequency of sound will also be increased. So it means that if likewise, if the source is moving away from the listener, then the frequency of sound may decrease. So it means that when there is a relative motion between the source and listener, then the frequency of sound may change. So this change in frequency is called the apparent change in frequency. That change in frequency is called the Doppler's effect. Now we are discussing some cases in Doppler. So we are discussing case number 1. Suppose when a sounding source moving towards a stationary listener, then when a sounding source moving towards a stationary listener, this is actually case number 1. Okay, now let us consider this is a doll and this is a person, a listener. The speed of the listener is called b. B is equal to 0. 0 means it is at rest. So the speed of the listener is 0. It means the listener is at rest. So this is the speed of sound approaching to the listener. So the frequency heard by the listener is f. Okay, this is the frequency heard by the listener, that is f. Suppose when the source start motion towards the station listener, that speed is called a. So a is the speed of source. So a is the speed of source, and the speed of source is towards the stationary listener. Okay. Now we know that frequency of sound is equal to v by lambda. This equation is 1. Frequency is equal to v by lambda, and we know that the lambda and the frequency are inversely. If the lambda change, the frequency will be changed. So I placed a prime sign on the lambda as well as on the frequency. Okay, now look at here, lambda is equal to v by f. Here in this equation, lambda and speed both are directly proportional. So it means that when the speed is changed, lambda will be changed. And we know that, look at the diagram. In the diagram, the speed and both the speeds are same in direction. So if both the speeds are in same in direction, so their relative speed will be v minus a. So what will be the relative speed? That will be equal to v minus a. We already studied it in collision that when the two speeds are in same direction, their relative speed will be v minus a. Okay, now putting the lambda prime in equation 1, putting this equation, putting the values in equation number 1, we get, okay, so f prime is equal to v by lambda prime. So putting the value of lambda prime here, so it will be v minus a divided by f. So it will be v by v minus a into f. So the apparent change in frequency will be v minus a into f. So this is the frequency, the apparent frequency when the source is moving toward the stationary listener. This is the apparent frequency. Okay, now what does this equation tells about the apparent frequency? So look at here. Here the numerator consists of v and the denominator consists of v minus a. So tell me which is greater, numerator is greater or denominator is greater? So it clearly tells that the numerator is greater because there is a subtraction in the denominator. If there is a subtraction in the denominator, so it means that numerator is greater. So if the numerator is greater, what does it mean? It means that the apparent frequency will be changed, will be increased. Suppose if I took 7 by 1, so which is greater? Numerator is greater, denominator is smaller. So it means that if you multiplied 7 with the old frequency, then you will get the new frequency. It means that the new frequency will be increased than the old frequency. So according to common sense, we observe that when the source is moving towards the stationary listener, then the frequency of sound will be increased to that of listener. So it means that the frequency observed by the listener will be much greater than the original frequency. So it means that upper frequency will be increased, and this equation also tells about the frequency will be increased. Okay, now we talk about the case number 2. Case number 2 is when the sounding source moving away from stationary listener. Okay, now we are discussing that the sounding source is moving away from the stationary listener. Suppose we have a stationary listener, the speed of listener is b and b is equal to 0. B is equal to 0 means the listener is at rest. Okay, now we have a dole. This dole is initially at rest and it is ringing, so it means that it is producing a sound. Its speed is v, its frequency is f. Now if the source is start moving away from the stationary listener with the speed a, so a is the speed of source away from the stationary listener. Okay, now what is the formula for the frequency? A formula for the frequency is f is equal to v by lambda. This label is equation number 1. Okay, remember, if lambda change, frequency will be changed. Frequency and lambda are inversely proportional. Okay, now equation for the lambda is equal to v by f. Okay, this is the frequency, this is the equation for lambda. Now remember, here speed and lambda both are directly proportional. So it means that if the frequency is the speed increased, lambda will increase. If the speed is decreased, the lambda will be decreased. Okay, speed and lambda both are directly proportional. But look at here in the diagram, the speed v is moving towards right, the speed of sound is towards right, and the speed of source towards left. So both are oppositely directed. If both are oppositely directed, so their relative speed will be added. So we already studied in collision that the relative speed in opposite direction will be always added. So add the two speeds, so it will be v plus a. Okay, so the relative speed will be v plus a. So putting the values in equation number 1, so what we will get, so putting the values in equation number 1, we get, okay, so it will be f prime is equal to v by lambda prime. The value of lambda prime is v plus a divided by f, so it will be v by v plus a into f. So the final equation is v by v plus a into f. This is the final equation. So look at here, look at this equation. uh, Tell me, numerator is greater or denominator is greater? Surely you will notice that the denominator is greater, because here the two speeds are added. A is the speed of source, V is the speed of sound. So both the speeds are added, so it means that the denominator is greater than the numerator. For example, if I took the example 1 over 7, 1 over 7 means numerator is smaller, denominator is greater. So it means that if the denominator is greater, what does it mean? So shift the 7 to the right side. So it will be 7f prime is equal to f. It means that if you multiply 7 with the new frequency, so you'll get the old frequency. It means that the old frequency is greater than the new frequency. So in the common sense, if you observe that the source is moving away from the stationary listener, it means that the listener will observe a much smaller frequency than the original frequency. So this is case number 2. Okay. Now case number 3. A listener is moving towards the stationary source. Now we take the stationary source now. Now the source is stationary actually. Now the listener is moving. Suppose we took a doll which is at rest. So this doll is at rest. And this is a listener, a person. So if this is ringing, so it is producing sound with speed v, and it is reaching to the listener frequency f. Now the listener is moving towards the source. The listener is moving towards the source. Okay. So if it is moving towards the source, now again look at the equation. I'm turning the page. Okay. Now look to the inner page. The equation is f is equal to v by lambda. This is the equation, f is equal to v by lambda. This label is equation number 1. Look at equation number 1. In equation number 1, we notice that the speed and the frequency both are directly proportional. But I place a double prime on the frequency. Why? Because to differentiate the motion of source and listener. In case number 3, there is a motion of listener. So it means that we take a little bit different representation of frequency than the motion of the source. Okay. So if you take a single prime, then you can take it. It doesn't matter. So I took a different representations. That is why I took double prime. Okay, now look at the diagram. In the diagram, if you notice down, if you look at the diagram, in the diagram it is that these are the two speeds which are opposite to one another. If these two speeds are opposite to one another, so their relative speed will be added. So it means that the relative speed will be added because both are opposite to one another. So here, putting the value of v prime, that is v plus b. Why there is a v plus b? Because look at the diagram. In the diagram, the two speeds are oppositely. Look at the v and b, both are oppositely. So that is why I added the two speeds. So the relative speed is v plus b. Now what is the value of lambda? The value of lambda is actually v by f. The value of lambda is actually v by f. Now shift the f in numerator, so it will be v plus b divided by f. Now this is the final equation. Now first let's have a look what this equation tells about. This equation tells that the new frequency is greater than the old frequency. How? look at the numerator. Numerator is greater than the denominator. The numerator is greater and denominator is smaller. So it means that the new frequency is much greater than the old frequency. So it means that whenever the listener is moving towards the source, then the frequency of sound will be increased. Okay. Now, case number 4. If you took case number 4, a listener is moving towards, a listener is moving not towards, away from the stationary source. A listener is moving away from the stationary source. Okay. Now here, the source is also at rest. Now the listener is in motion, so the motion of the listener is away. The speed of listener is b, speed of source is a, and a is equal to 0. A is equal to 0 means the source is at rest. Now if the dole is ringing, so it means that the frequency f heard, the frequency heard by this listener is f, that is original. But when the listener starts motion away, so it means that this person will observe a different frequency. So now look at here, the equation for the general equation for the frequency is f is equal to v by lambda. This label is equation number 1. Now look at here, v and frequency both are directly proportional, so if speed changes, the frequency will be changed. So I placed a double sign, a double prime. Why double prime is placed? To make it different case from the case 1 and case 2. In case 1 and case 2, we placed a single prime because that was the motion of source. In case number 3 and 4, we placed double prime because this is the motion of listener. Okay. Now look at the diagram. Here the speed of sound and the speed of listener both are in same direction. If the speed of sound and speed of source both are in same direction, so the relative speed will be subtracted. So putting the values of v prime here, so it will be v minus b. Okay. Now what is the value of lambda? The value of lambda is v by f. This is the value of lambda, v by f. Now shifted f in the numerator, so it will be v minus b divided by v into f. This is the final equation of apparent frequency when the listener is moving away. Okay. Common sense tells that when the listener is moving away from the stationary source, it means that the frequency will be decreased. Look at the equation. Look at the numerator and denominator. We observe that the denominator is greater because there is a subtraction in the numerator. So if there is subtraction in the numerator, so it means that the denominator is greater. If the denominator is greater, so it means that the apparent frequency will be decreased. So the apparent frequency will be much smaller than the original frequency. So this is case number 4 when the listener is moving away from the stationary source. Now case number 5. What is case number 5? Now look at here. Now source and listener both are moving towards one another. Now source and listener both are moving towards one another. Okay. Here we have a source and here we have a sound. Okay. Now this is the speed of sound v and frequency heard by the listener is f. Okay. Now the source is moving with the speed a towards the listener and the listener is moving with the speed b towards the source. So both are moving towards one another. If both are moving towards one another, look at the equation f is equal to v by lambda. Equation number 1. Okay. Now look. Lambda is inversely proportional to frequency. If the lambda change, frequency will be changed. Okay. So I placed prime and the lambda in frequency. So if we talk about the source, so we should talk about the lambda. If the lambda changed, frequency will be changed. Now look at here. If the listener is moving towards the source, so it means that speed will be changed. If the speed is changed, frequency will be changed. So I place a triple prime as a frequency. Why a triple prime? To differentiate this case from the case number from the previous cases 1, 2, 3, 4. Okay. Now, first look at the equation of lambda. The equation of lambda is equal to v by f. Now, first talk about the source. So if the speed is changed, lambda will be changed. So what is the relative speed in case of source? So look at here, the speed v is towards right and the speed of source is also towards right. So both are same direction. They both are same direction, so their relative speed will be subtracted, so it will be v minus a. So the relative speed is subtracted, that is v minus a. Now this is the value of lambda prime. Now look at the source. Look at the listener. Here, the listener and the sounding source are opposing to one another. If the speed of sound and the speed of listener are opposite to one another, so it means that the relative speed will be added. So I will write v plus b. Now putting the value of v prime and the lambda prime in equation number 1, so we will get. So look at the equation number 1. In equation 1, f triple prime is equal to v prime divided by lambda prime. So what is the value of v prime? The value of v prime is v plus b. And what is the value of lambda prime? The value of lambda prime is v minus a divided by f. Now here f is present in the double division, so shift it up. So we will get f triple prime is equal to v plus b divided by v minus a into f. So this is the final equation of the apparent frequency. So what this equation tells about? So first, look at the common sense. When the source and the listener both are moving towards one another, so its frequency of sound observed by the listener is very, very high. So this is the common sense. We observe the apparent frequency will be very, very high. But look at the equation. In the equation, we notice that the denominator is greater and the denominator is smaller because there is addition in the numerator and there is a subtraction in the denominator. It means that the numerator is greater than the denominator. If the numerator is greater, so it means that the apparent frequency will be much greater than the over frequency. So this is the equation of apparent frequency tells that when the source and listener both are approaching to one another, the frequency of apparent frequency will be much greater than the old frequency. Okay. Now case number 6. This is the last case. Case number 6. Source and listener both are moving away from the stationary, not stationary, both are moving away from one another. Both are moving away from one another. Okay. Now this is the source, this is the listener. The source is ringing, so it means that if it is ringing, so it's producing sound v, and the frequency heard by the listener is f. And look at here, if the source start motion away from the listener and the listener starts motion away from the source, so its speed is called a, its speed is called b. Now look at the equation. The equation is v by lambda. This is equation number 1. If we talk about the source first, so if the lambda change, frequency will be changed. Frequency and lambda both are inversely proportional. And now look at the listener. If the speed is changed, if the speed is changed, frequency will be changed. So I place a triple prime in the frequency. Okay. Now first look at the source. Lambda is equal to v by f. If we talk about the source, speed and lambda will be directly proportional. If the speed is changed, lambda will be changed. Now look at the speed, the relative speed. The speed of source is a towards left and the speed of sound is v, which towards right. So both are opposite. If both are opposite, so the relative speed will be added. So the relative speed will be v plus a. So this is the equation for lambda. Now what is the equation for the relative speed of source? Relative speed of listener. So look at the speed of listener is towards right and the speed of source is towards right. So both are same in direction, so their relative speed will be subtracted. So this is the relative speed of the listener. Okay, putting these values in equation number 1, so we will get, so f triple prime is equal to v prime by lambda prime. So what is the value of v prime? That is v minus b. What is the value of lambda prime? That is v plus a divided by f. Now shift f in the numerator, so we will get v minus b divided by v plus a into f. This is the final equation for the apparent change in the frequency of sound. Okay. Now, this is the final equation for the apparent frequency of sound. So what does this equation tell us about? This equation tells that when both are moving away from one another, its frequency of sound will be decreased because numerator is smaller, denominator is greater. If the denominator is greater, so it means that the apparent frequency will get smaller. So the apparent frequency will be very, very smaller than the old frequency. So this is case number 6. This is all about the 6 cases of Doppler effect. If you find any question, any confusion, then you can ask in the comment section. Okay, take care. Allah Hafiz.